Mercury rising. How does temperature relate to kinetic energy? Recall that temperature is a measure of the average kinetic energy of all the particles in an object. In the photo on the previous page, a person pours a cup of hot tea next to a large lake. The average movement of the particles that make up the lake is slower. In the warmer tea, the average movement of the particles is much faster. If an iron, which is a solid, has a high temperature, the iron's particles are vibrating very fast and have a high average kinetic energy. If the iron has a low temperature, the iron's particles are vibrating more slowly and have a lower average kinetic energy. Absolute zero is the temperature at which the motion of particles stops. It is not possible to actually reach absolute zero, though temperatures very close to absolute zero have been reached in laboratories. How is temperature measured? Suppose you hear on the radio that the temperature outside is 30 degrees. Do you need to wear a warm coat to spend the day outside? The answer depends on the temperature scale being used. There are 3 common temperature scales, all of which measure the average kinetic energy of particles. These scales are called Celsius, Fahrenheit, and Kelvin. However, 30 degrees on one scale is quite different from 30 degrees on the other scales. To establish a temperature scale, 2 known values and the number of units between the values are needed. The freezing and boiling points of pure water are often used as the standard, known values. These points are always the same under the same conditions, and they are easy to reproduce. In the Celsius and Fahrenheit scales, temperature is measured in units called degrees. Degrees are equally spaced units between 2 points. The space between degrees can vary from scale to scale. In the Kelvin scale, no degree sign is used. Instead, the unit is just called a Kelvin. Temperature is measured using an instrument called a thermometer. So we have our 3 types of scales. We have our Celsius scale, our Fahrenheit scale, and our Kelvin scale. What we typically use is the Fahrenheit scale. But let's read about the Celsius scale. The temperature scale most commonly used around the world and often used by scientists is the Celsius scale, which is abbreviated with a degree symbol and a C. This scale was developed in the 1740s by Anders Celsius. On the Celsius scale, pure water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. So there are 100 degrees, 100 equal units between these 2 temperatures. Let's take a look at our Celsius thermometer. Water boils at 100 degrees. Body temperature, our average body temperature is 37 degrees Celsius. Average room temperature is 20 degrees Celsius, and water freezes at 0 degrees Celsius. Now let's read about our Fahrenheit scale. The scale used most commonly in the United States for measuring temperature is the Fahrenheit scale. It was developed in the early 1700s by Gabriel Fahrenheit. On the Fahrenheit scale, pure water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. Thus, there are 180 degrees, 180 equal units between the freezing point and the boiling point of water. Let's take a look at our Fahrenheit thermometer. Water boils at 212 degrees Fahrenheit, but remember it boiled at 100 degrees Celsius. Our average body temperature is 98.6 degrees Fahrenheit, but remember in Celsius our average body temperature was 37 degrees Celsius. Average room temperature is 68 degrees Fahrenheit, but remember in Celsius it was 20 degrees Celsius. And water freezes at 32 degrees Fahrenheit, but remember water froze at 0 degrees Celsius. So notice how these compare. Our last scale is called the Kelvin scale. The Kelvin scale is a temperature scale used commonly by physicists, which is called the Kelvin scale. This scale was not developed until the 20th century. The equal units in the Kelvin scale are called kelvins, not degrees. On the Kelvin scale, pure water freezes at 273 kelvins and boils at 373 kelvins. There are 100 kelvins, or 100 equal units between these 2 temperatures. The lowest temperature on the Kelvin scale is absolute zero, or 0 kelvins. So you can compare water boiling 373 kelvins. Body temperature, 310 kelvins. Notice what it is for Fahrenheit and Celsius. Average room temperature, 293 kelvins. Notice what it is for Fahrenheit and Celsius. And water freezes at 273 kelvins. Notice what it is at Fahrenheit and Celsius.